Clicker doesn't work, does it? Does it work? Yeah, it works? Okay, cool. All right. So, it's working? Nice, good job. Fantastic, thanks, mate. Okay, round of applause for our technical help. Yay! Let's go back a little bit. Okay, who am I? My name's Rob Hawthorne. I am a principal consultant for Theta in Wellington. We focus mainly in Wellington, we focus mainly on Microsoft BI solutions. But during my career, I've done all sorts of horrible, nasty things. But I've also worked with the SQL Server platform since version 6.5, focusing mainly on high performance and scalability. And my little pictures keep drawing all the time. Once upon a time, I actually wrote a book, as you can see there, SQL Server database development from scratch. And you can't buy a copy of it anymore, I'm sorry. Not a physical copy, at least. You can buy an electronic version of it, and it'll cost you about 50 cents. I also, back in 2002, 2003, 2004, competed in the rock radio station's wife carrying competition and won it 2 years in a row. And the best thing about that is you win your wife's weight in beer. For some reason, my wife is quite small. There she is, hanging over my shoulder there. But she seemed to weigh quite a bit when we weighed her in. It helped that the other contestants stood on the scales, right? Now, getting up and doing these presentations is always a bit difficult. It's always a bit hard to get into the swing of it. So, you know, like when you guys get up in the morning, you go to work, you need your coffee, to get yourself motivated and powered on. It's pretty much what it's like here. So it might start out a little slow, and then it's probably going to go flat in the middle because my Red Bull will start wearing off. And then by the end, I've just had swag to give you so you guys will be happy at any rate. So, here we go. So this session's all about performance tuning for analysis services, but there's very little code, okay? And the reason why there's very little code is what is the main thing that you need to get right to ensure that you've got a high-performing system? Memory is one. Even more basic principles than that, even before you actually install any kit. Ah, you got it. All right, we'll give him a water bottle. Can somebody pass that backwards? I've got some lovely assistants here to help me somewhere. Where are my lovely assistants? Oh, there he is. Come on, Vince, you've got to be my lovely assistant to give stuff out for me. Round of applause for Vince. Yay! We're going to give Vince a hard time because he went home early last night. I stayed out later than he did. Right. So, if you don't get your design right, it's not going to work, okay? It doesn't matter what you do, you will never make your system work. But the way that the way that you get your design right is by looking at the roles that you have available. So, what we're going to do is we're going to look at the 3 different roles that are required. Now, there's more roles than this required to actually make sure that you build a true BI solution, because you've got to have a BA and a project manager and a tester and all those sorts of good roles. But this is focused on performance. Right, so that's why we're dropping those particular capabilities out of this. So let's have a look at our good old systems administrators. I'm going to say something really surprising here. Big is better when it comes to hardware. It is. There is nothing worse than hardware that is under-designed for what you are trying to do. So, think about your hardware. There's lots and lots of bits associated with it. So you've got network and CPU and memory and disk, etc. And now I'm going to pause, just randomly, because that's what I was looking for. Found it. Right, so I need to give some questions, because otherwise I'm never going to give all this bling away. Can somebody think of a question? What's a good question? How do you know what sort of size system you need before you get started? You guys got to speak up. Good. So, how do you begin to start getting onto that scope? I can throw those ones at you, mate. Sorry, say that again. Find out what the business needs are, and how are you going to do that? How does that affect your size of your hardware? Getting out and talking to the people, right? So you can get number of users, because that's going to affect your hardware. You can get a size of the data. So you can then begin to make some extrapolations that you need this many users for this much data, okay? That's good. find some more bling for you. What have we got? Wow, it's just so much stuff. Oh, here's a t-shirt. Here we go, mate. Okay. Oh, sorry. Throughout the slide deck, and you must excuse me because I was very slack, and as long as Anna's not in the room, I won't get in too much trouble. I never actually did my slide deck until yesterday, so that's why it's not actually available on the portal. But if you want it, email me, you can have it. But throughout the slide deck is links to some extremely good guides. So this link here is for the Windows Server Performance Tuning Guide, and it covers things like Active Directory servers and file servers and things like that. The stuff that you need to do at the base level before you go anywhere else. Right, a network. You think NIC configuration would be something that most people actually spend time looking at, but they don't. Network cards, for some reason, are totally ignored. People seem to think that you just plug a network card in, put an IP address on it, and away you go. But it's not quite true. There are some things that you can do to actually, A, increase your scalability and your performance, like in this scenario here, we have what's called a scale-out read-only database tier. Now, you might have heard Nick Dritzis talking about this yesterday. Was it yesterday? Yeah, yesterday. So basically what it is you have a network load balancer that sits over the top there, and that can be either a hardware device, or it can be an NLB product that ships out of the Windows box. We've actually implemented this for a customer in Christchurch who was having performance problems. And what this allows you to do is that if you've got a really big cube that's taking a long time to process, who here's got a big cube? I have too. Sorry, that's a bit soon. Okay, what sort of sizes are we talking about? That's a decent sized cube. Nice. Anyone beat that? 7? 70. Nice. Stats? Do you work for Stats? That's you. Stats have a very large cube too. Good try, John. So when you've got a large cube, they take a long time to process, even if you're not doing a full process. And what that can end up doing is locking and blocking the users from actually executing queries. So in this scenario here, you can have one server that's sitting there processing the cube in the background, and another server that's sitting there taking user requests. And when that cube is ready, you dynamically switch them from one to the other, and then you copy the cube over. It's actually very simple to do, and it's extremely robust. So, but you've got to get your network right, okay? And the other things you've got to watch out for are things like Kerberos. Because analysis services will only allow you to do Windows-based authentication, Kerberos is normally the way that most people move forwards. You could use service accounts with hard-coded passwords in them. But if you implement Kerberos, what you've got to watch out for is it's extremely chatty. Because what happens is I log onto my PC in the morning, I get a ticket, I then go and access the box and pass that ticket as part of that. Well, actually, initially when I make the request, I don't pass my ticket. I make a basic request. It then says, hey, are you authenticated? I say, yeah, here's my ticket. That then takes that ticket and goes off and talks to the domain controller and goes, is this ticket valid? Yes, that ticket's valid. Okay, Rob's allowed in and it can access this data now. Okay, so you're getting all this chatter going on all the time. So you have to watch out for that on your network. Additionally, it depends where your SQL server is. So if you have analysis services and SQL Server on the same box, you can get away with using things like local host connections, etc. If they're across a network, you have to allow for the fact that if your cube's building and you've got a 70 gig cube, it's going to take a long time to copy all that data off the SQL box and onto the analysis services box. Okay? Right. There's a couple of config options that you have available to you in analysis services that should allow you to tweak and modify the way that analysis services works. So one of the recommendations is to look at compression, because if you enable compression, it'll compress the data as it's streaming into analysis services. Good for that scenario where you have a large SQL cluster and a separate analysis services box. And also fix the port. Do you know what I mean by that? It's not broken, but fix it. Give it a specific port number to operate on. Sorry, I can't open my bottle. Okay. Oh, I can build scale-out architectures, but I can't open a water bottle. So, by default, analysis services will pick up a dynamic port. which is fine. You can use a dynamic port, but if you have a fixed port number, it means that all your things, so you won't need things like the SQL browser service running, because the SQL browser service is what actually redirects your connection through to analysis services. That's what picks up the dynamic port. Right. What's the next most important thing? CPU. Why is CPU important? Yeah. And why do we have multi-core CPUs? Somebody said it began with P. Vince, can you give that to that lady in the red, please, mate? Who said parallelism? Yeah, good man. Right, okay. Oh no, the lady in the red gets a pen, he gets a water bottle. Yeah, see, come on. My pretty assistant needs some guidance. It's hard, these blondes, eh? You have to forgive him because he's worried about tomorrow night and the South Africans losing, because we know it's going to happen, right? Even without King Richie there. I just said this publicly. I might regret to live, oh, God, forget it. Okay, but the other great thing about CPU and multi-threading is that it actually can help your disk performance. So what that allows us to do is if we've got multiple spindles inside our machine, and we've got multiple CPUs, we can create threads for each of those spindles to actually make that entire process work faster. That's what the parallelism does. So we redo it from all of these different drives, and then we combine them together and we get a result set coming back. And there's two types of processing options inside analysis services. So you've got your query processor, which is for your user requests, and then you've got your processing configuration, which is for actually processing your cube and how you hold it on disk underneath the hood. So multi-threading will allow us to do those operations faster and more simultaneously. Additionally, multi-threading and getting our CPUs right will allow multiple user connections to come in, so we can spawn more threads and deal with it in that way. Okay, so don't underestimate your CPU. So I just checked my internet connection's working. Oh, look, it is. Great. Sorry, guys. 2 seconds. I've just got to reconnect because it didn't get a nice big display. There we go. Okay. Now, this is a lot more harder on virtualized kit because you get 4 virtual CPUs. So just think about it if you're building virtual machines, that you are potentially not going to get the same throughput that you would on your hardware for high performance cubes. But if you've got a 70 gig cube and you've got it virtualized, it's probably not going to perform particularly well at any rate. Okay? It's going to be all right for a scale out read-only tier. If you spawn up enough virtual machines, you could probably make that work very well. But the actual processing of that cube, you're going to have to be very careful with. There's a few options there for going and modifying it's the SSAS config options. Do you guys know what I'm talking about with these config options? You know where to find them? Yeah, Management Studio, right-click Properties. You can get it there. Or if you're like most people, you can go in and hack the .ini file, because that's all it generates underneath the hood. Just back it up before we make any changes to it. Okay. In analysis services, there's 2 types of memory. I wish I had 2 types of memory. Well, I guess I probably do. I've got long-term memory and short-term memory. And I guess it's the same sort of thing for analysis services. So we have shrinkable memory, which is dynamic and it can adjust. And those are things for the user queries. And then we've got non-shrinkable memory, which the only thing that can get that memory back is the operating system. So if the operating system starts paging really, really badly, it can go and make the request to analysis services to give some of that memory back. This feels weird. I've just got screens everywhere. Right. So, if your operating system starts paging, what's that going to do to you? Increase your response times? How? How is it going to increase your response times?
Service your request, it'll have to page data in rather than being able to service it out of the memory, so you've got all your IOs you've got to wait on.
So the way that it works, and somebody else over here said IO requests, is if your memory is full, Windows will write out to the page file. And if it's writing out to the page file, that increases your IO because it's a physical file on disk. The amount of SQL Server environments I've seen where people leave the page file sitting on the C drive Not the best idea. Try and put it onto its own spindles. Nice fast disk, but even better, try not to actually have it paging. The other thing you've got to watch out for is the size of the page file, because by default they're 1.5 times the memory space. And of course, the larger the page file is, the bigger file that you have to deal with. Small files are very, very good. Lots and lots of small files. They're a bit of a nightmare for management, but more smaller files will do you better than single larger files. So, we got a little bit there on how memory works inside the OS. I think most of you know that 64 gig is pretty much a flat memory addressing space, and 32-bit has the old 4 gig virtual address memory space inside it, which is split into two. We've got system and we've got user, and which bit does analysis services reside in? User, there we go. Okay, we need some, who said it, Vince? Oh, my pretty assistant. God. You'll just have to go and find someone for a pen, mate. Oh, hang on, that's the last pen. Oh, wait. Pen's got to go with the book, bud. Hang on. Yeah, so we've got to have people tell us a question. Okay. So, because you've got that 2 gig user memory space, you can fill that up pretty quickly. And what you've got to watch out for is something called the Windows file cache. And the Windows file cache is what actually reads the files off disk and stores them in memory for you. So you might have a box that's got 32 gigs of RAM, and you've got a cube that still performs really, really badly. You'd expect it to load a 16 or even a 5 gig cube fully in memory, but it can't, just because of the limitations of the file system cache. So what you have to watch out for is if you've got a really large cube, you've got to go and change a couple of parameters. So first of all, you've got to set this lock pages in memory right for the service count. What I mean by that is to go into the security policy on the machine and modify that. And then you've got to have a look at limit your file system cache megabyte size. So make that bigger, because by default I think it's only about 4 gig, 4096 or something. You'll see the options inside analysis services. So this will allow you to load more of the files into memory so that you can deal with your query response times. See why design's important? Yeah? Yeah, come on. Oh, we're starting to go a bit flat, guys. Come on. I know the hangovers must be just about, you're getting to the worst part of it right about now. Did anyone have a really big night? 1, 2, 1.5. It was really so enthusiastic he couldn't even lift his arm up. It was like, oh my God, that's too much. Anyway, but here's a t-shirt for having a really big night, dude. Okay, so some configuration options for you for memory. Just go and spend the time researching these configuration options. There's a whole pile of them that are there that you think, oh, that sounds like an interesting one, but it's got a flag on it that says, do not change unless advised by Microsoft support. I suggest you do not change unless advised by Microsoft support. Okay, one of the most critical components for analysis services. And I think this is even more critical than memory in a lot of ways. Your disk, just like it is for SQL Server databases, is absolutely key. And if you don't get this right, you're going to get into a lot of trouble very quickly. Now, like SQL Server, Analysis Services has a bunch of different things working on underneath the hood. So it has a temp directory, very much like a temp database. It's got a log directory. It's got data files. You have to allow for partitions, where you're putting your backups. It also has a component called the flight recorder. Do you guys know what the flight recorder is? Somebody going to tell me, or just you? Yeah, and that flight recorder can actually get quite large. So watch out for that file. You can also catch it you can also configure it to catch the user queries that are coming into analysis services. So it can grow very quickly, very much like a profile trace. And your page file. Now, I've said RAID 10 is absolutely great, but SSD is even better. Okay, so if you can put analysis services databases on SSD drives, you're going to get awesome performance. Except if you've got too many of them. Yeah, then you've got to figure out a way of cooling it, right? Not my problem. That's what we have air conditioning guys for, right? So, But the other thing to watch out for SSD is that you don't get the life out of those drives that you get out of a typical SATA or IDE drive. Now, the other good thing about analysis services is you can have partitions in your cube just like you can have partitions in your database, which allows you to separate your data. So you can take your old or legacy data or previous financial year or whatever it is and put that onto older, slower disk, and you can put your high performance current data that always needs updating onto fast SSD drives. I think I'm killing that poor guy. His head's down. He's like, oh no. So, make your partitions in your cube small enough to be able to be dealt with. We'll get to the design of the cube shortly. As long as I don't run out of time. That's one of my big questions here, isn't it? Because you guys want to get into the lunch queue before everyone else, right? There's some configuration options for disk as well inside analysis services. Oh, one other thing I forgot to say. Sometimes if you have, you've got direct attached storage inside your machine, you go in and put yourself in a RAID card and you go, yeah, I've got a RAID card, it's all going to work really well. If you want the ultimate throughput, multiple CPUs, multiple RAID cards, so they can address disk, okay, because you'll get all that throughput going through, because otherwise all you're doing is you're moving your bottleneck from one place to another. Okay, so think about a total scale-out performance. That's what you've got to do. Every component that you're putting in for a very, very large system needs to be thought about. Right, SQL Server administrators. Pretty much everything that all DBAs know now still applies. So good practice. Format your drives correctly. Oh, here we go. This is a good question for a t-shirt. What should I format my drives for? Oh, is it on the slide? Ah! You all get a t-shirt. We'll have to go and talk to Dimmy. Okay, how about we do it this way? Why do we have 64 KB chunks? Okay, what size is an extent? No, it's 8. But it just means that we can load 8 of them in memory at once, or read and write 8 page files. Yes, thank you. 8 8s are 64. Yeah, that's right. I'm a little slow, okay? It's getting a bit old. So, now I don't know what to do with a t-shirt. We'll figure that out. So, yeah, make sure that you do all those standard practices for your SQL Server. So you guys know all this stuff, right? You know, you format your drives, right? You split your data files up across multiple disks. All of that totally matters for analysis services to get the fastest read performance it can from the SQL Server environment to build your cube. Yes?
Why would you split the log files?
Where? Multiple log files, because on a very large system, you can, for a database, you can actually create lots of log files, or 4 log files, or whatever it might be, and you set the size of those log files to being smaller so you can back them up faster, and it'll move then to the secondary log file whilst that one's being backed up, okay? So it just helps you to manage the size of those log files more than allowing to have one massive log file. We noticed this when we did a project for a customer just recently where we were replicating data from their JDE environment into the SQL Server world. So it was JDE on Oracle, and our log files blew out significantly because they pumped that many transactions through at the end of the month. It caused us massive issues. So we ended up setting and binding the size of the primary log file and then just adding secondary log files to it so we could just back them up. Keep them nice and small. There's no reason that your data warehouse needs to be in full mode either. Put it in simple mode. It's batch driven, it's not transactional driven, so you don't need transactional consistency. Now, specifically for SSAS, there's some things that you can do. Use partitions, right? It's always a good idea. Look at your indexing scheme. Make sure that you don't just use default primary keys, because that may not be what you actually need for servicing the requests for the dimensions. Update your statistics. Most people forget to do this as part of the end of their ETL run. They'll forget to set it so that you actually go and update the statistics inside the database, because you've just refreshed a whole pile of data. And turn off the flight recorder. Oop, why did I leave that in there? That should have been on the previous slide. Never mind. Now this is quite cool. Did you guys know that SSAS has DMVs? Dynamic management views, just like SQL Server has. Don't believe me? Okay, now we're going to try this out. Which button do I push, buddy? Yeah, we'll see if that... Yeah, we're getting it? It's gone. Oh. Okay, well, he's sorting that out. So we've got DMVs that'll expose all sorts of bits and pieces inside analysis services for us. There we go. Look at that. Which one? Just. Do I put? Oh, okay. They've got terrible names on it. It says wipe, cut, and mix. Randomly press buttons and see what happens, right? Okay. So, where did it go? Sorry guys, I've got a session inside a session here and I just can't quite see where it's gone. Oh, maybe I did close it. Oh, that's ISA server. Must be... Oh, I see. Sorry, apologies. I know what I've done. Do you like the name of my servers? All right, there we go. Do you know how hard it is to keep a naming scheme like Duckburg up and running? Because you start to run out of character names quite quickly. So you've got Donald and Daisy and all those sorts of things, but you have to start finding some unique and obscure ones. Clive found a Duckburg family tree for me once, and I think we've just about had every name that's possible on the list. Okay, so just like SQL Server, you have management views. They all begin with this dollar system, and then you've got basically the actual view that you're running underneath it. And if we go and look at that, we've got to discover sessions. I'll just hide all this stuff. And we can see who the user is. And we can see what they're actually accessing. You can actually go off and get the queries that the user executes underneath as well, if you wish to. Why would you do this? Why would you want to know about these DMVs? There we go. I might rephrase that just slightly differently. It's a nice way of putting it, though. What he said was by establishing to see who's actually using the system, right? One of the biggest problems with BI solutions is people connect to a cube via Excel. Who's using it? I've got no idea. So this exposes it for us, and it means that if we're going to make changes to the cube, we know the users that we're going to affect. So you could have a little batch job that ran this every 15 minutes, dumped it into a SQL table, and then had a report that went over the top of it or something. Be fairly simple to do. You've also got a DMV that, now the only thing with it, of course, is it can't use a good old go statement. And, there it goes. So you can actually see which database and which part of it is using how much memory as well. So it exposes a lot of capability to you, very much like the SQL Server DMVs. Right, now I'm going to try and switch back without cutting it off. This one? Tell me. Did it work? Yep. Yay. I've just upgraded myself to a button pusher. Cool, wait, okay. There's a whole pile of these DMVs available, and there's a link here that'll find them for you. Basic syntax, select star from blah. So it's very similar to the way that you write a SQL statement, which is actually quite nice because most people struggle with MDX. I know I struggle with MDX. I try and avoid writing it if I can. Right. One of the other roles that we need to look at is our developers. And as Steve Ballmer used to say, developers, developers, developers. Do you guys remember that? Yeah? Or am I just the oldest person in the room? The developer has a massive responsibility. Because what time do we finish, mate? We started at 11:55, we finished at what, sorry? What time? 5:02. Okay, so we've got heaps of time. Unless you guys want to get out early to get in the lunch queue first, right? So a developer has a big responsibility because if the cube does not perform well, the users aren't going to accept it and they won't adopt the cube. How many of you have had cubes where your query performance is horrible? Right. And what caused it? Bad design of the cube. Bad design of the cube. And it doesn't matter. Well, I've got a few chockies here. Hey, I can throw some. It doesn't matter how much hardware or tin you throw at it, you will never actually fix the performance of the cube, because if it's designed badly, it's always going to perform badly for a user experience. Your underlying data sources are going to affect your performance. If you do not have a good dimensional model for your cube, it's not going to work very well at all. So, generally speaking, the Microsoft toolset favors Kimball methodology over Inman. And that's actually probably fairly accurate at the moment, because pretty much all the data warehouses I've seen being built recently are all Kimball based. I don't know of any Inman based ones at the moment. Anyone got an Inman based data warehouse out there? Do you even know what I'm talking about? No one's got one. Everyone's Kimball? Yeah, Kimball's the way. Kimball's the way. So, as long as you get your design of your data sources well structured, gosh, having brain fart moments. As long as you get your data sources design structured effectively so that you get a nice little star schema going on, you are going to have a better chance of getting better performance out of your cube. Snowflakes are going to cause you issues. Good dimension design is key to your good performance of large cubes as well. So what we mean by that is only bringing through things that people actually need. Only to make sure that you have good hierarchies inside your cube, to make sure that you have good indexes on your underlying dimensional tables. Now, there's a tricky thing that you can do, if you wish, is that the first user who comes in and requests a query from a cube has to build the cache in memory. So what you can do is you can actually run a script which will go and build that cache for you. The problem, of course, with a cube is what? Size could be 1. What do cubes allow us to do? Slice and dice. And what does that mean that we know the path the person is taking? No. Right? So that's the challenge. How do we cache everything that every user might do on every cube? Not a bad point, right? So that's where we start to get into trouble. And what's one method of helping to resolve that issue?
Dynamic management cubes to see what the most common used.
Yeah, that's right. I've got a few chockies here, courtesy of the heritage. I'm not afraid who I steal my bling from. No, the bathrobe there is actually it's actually a SQL master one. And we're getting down to it. Oh, we've just had the bathrobe and the 2 speakers left. Okay. So trying to build a cache for every possible scenario in a cube is very, very, very difficult. And one of the methods you can do is put some lightweight server-side profiling on to capture user requests and see what they're doing and actually preempt that. Or you can actually design your cube right and not have to worry about it. I say that with a little bit tongue-in-cheek because it's not that easy to do. So try and keep your cubes as simple as possible. If you get into creating really complex dynamic cubes, you are going to get into performance issues in large sets of data very quickly. Okay? Oh, excuse me. So a star schema is much easier to manage than a snowflake, and I try and avoid people doing snowflakes. I don't even like bridging tables. I think in my entire career I've built 1 bridging table. I hate them that much. I try and avoid using them. Even things like type 2 slowly changing dimensions, I try and steer users away from. Because when you're browsing that on a cube, it's actually very hard to see what's changed. With your hierarchies, there's 2 types. There's natural and unnatural hierarchies. Now this has got to be worth the bathrobe. Right? And if you win this bathrobe, you've got to wear it. Who can tell me the difference between a natural and an unnatural hierarchy?
Attribute relationship.
What do you mean? It's even more simple than that.
There's a single parent for every child you get, so the children run up to one parent and they run up to one parent. So you don't have a child that can have two parents.
That's a more like a ragged hierarchy, right? It's not an unnatural hierarchy. Come on, unnatural is really easy. Go.
So like natural is like normally here, date dimension, date hierarchies,
Yeah.
and unnatural is like when you manually create some. Manually you just create the hierarchies for some other.
For unnatural hierarchies, everything is based on the key attribute and there's no relationship between the actual attributes. And for natural hierarchies, you embed the relationship into the dimension structure.
Can you say that first bit again?
For unnatural hierarchies, everything is based on the key attribute. And there's no relationship between the levels of the hierarchy. And in the other case, for naturals, there is a relationship between the levels of the hierarchy.
There you go. Right. So, a classic example of it. You got to put it on. Actually, you can't. I'm gonna really embarrass you now. You've got to put it on, come up at the front, do a twirl, so these guys can see what these bathrobes look like. So, a common example of a natural versus unnatural hierarchy. A natural hierarchy: street, suburb, state. Street, suburb, city. Sorry, we're not in the US, so there's no states. Or an unnatural hierarchy is a combination of gender and education. There's no real relationship between it, and you have to build those hierarchies manually yourself. So the other thing that we also notice is that people don't use the keys. So when you build a star schema, you've got this nice surrogate key, and they don't use the surrogate key for the actual value on top of the attribute inside the cube. So let me just see if I can switch to this again. Ooh, I pressed two buttons at once. That might have been a bad idea. I've been fired as a button presser. Here we go. So what I'm talking about is if we just look at the property of state here, we can go and change its key column to using the surrogate key rather than the actual value, rather than the actual value, but we then also make sure that the value column is set to the state attribute. We do the same with name as well, set that to the key. And the reason why is that we've got a much smaller data type that we're dealing with, and it's indexed, not indexed, but it's a much smaller data type that we're dealing with, so you're going to get much faster performance when you're processing your cube. Okay? So use your surrogate keys wisely, but make sure that you get your display correct as well. Hey, I'm back. Okay. Calculations. I have seen some cubes where you have calculations built on top of calculations built on top of calculations. And I don't know why people do this. And most of the calculations could actually be done in the SQL engine prior to it actually being done in the cube, which will give you a better result at the end of the day. It's going to perform faster, right? So if you can, move your calculations to the database. If they're simple enough to do, move them to the database. If you have to build an MDX calculation, oh, you're not putting it on. Come on, man. Come on. Come on. Who wants them to put it on? Yeah. These things are pretty sexy. He's going to go home and get some. Yeah. Okay, come on, do a twirl. Show everyone what it looks like. Let's see. Woo! Good man. So, if you can move your calculations to the database, do so. Now, I am also a strong component of using views, which we shall see in our design principle. And the reason I use views is that I can use things like with no lock, because we don't care about transactional consistency. And if we can use with no lock, it means that we don't have the overhead of taking locking out on the database when we're trying to process a cube. You can also do nice things by having derived values that you don't need to store in your data warehouse. So, for example, you might have a full name attribute and you've already got first name and surname stored in your database, in your view, you can just simply combine those two together. You don't need to actually store that data. So use views all the time. But in my simple example here, we don't, and I'll show you. As John said earlier, your attribute relationships are absolutely key as well. You've got to make sure that they flow correctly, otherwise you're going to get into issues with those, not into challenges where you are doing more queries when you're processing your cube than you actually need to. Only keep what you need in your dimensions. How many bloated cubes are there out there? So with your 70 gig one, is it nice and trim? No. See, yeah, it's growing over time, right? And now it's to the point where nobody actually knows what's needed in the cube anymore. And that's one of the problems with cubes. Because everyone goes, woohoo, let's build this little data warehouse and we'll whack a cube on it and now away you go. And then you don't monitor it, maintain it, and you go, oh, yeah. Now it's starting to perform slowly because it's growing quite a bit. So what can we remove? And it's very difficult to remove it. As I said, use your surrogate key for your key columns property. And we use our views to also filter data out. So one of the things you can do is in your date dimension is join it to your fact tables so that you don't have dates going back to 1972 when you don't actually need them. A lot of people have very, very large date dimensions that go a long way back and their data doesn't support it. So it's kind of pointless. So the nice thing about having a view that's joined to the dimension, having a dimension that's joined to the fact table on your surrogate keys inside a view means that you just filter out all that noise, and if new data comes in that does support it, it just automatically appears when you process your cube again. Okay, so there's just some little tricks and techniques that you can get around having bloated dimensions.
So you said views.
Yeah.
You were talking about the database views or the data source view.
Oh, sorry, yeah, good point. Okay. I am talking about database views. I do not like seeing SQL sitting inside the DSVs. Okay, so not the data source views on your cube definition, but your views inside your database. And you can, because you get better control with it. This is a good question though. There we go, you can have a JBL speaker. Now these things are supposed to be quite good. I've never tried one, but they're supposed to be wireless. So yeah, I don't know how it's going to work. This chap just here. Oh, we're down to the last item. Ooh, last one. You see all you guys are going to get up and leave as soon as I give that out, eh? You're like, right, we're out of here. See you, mate. So, your network packet size. Most people don't modify this either. So if you have your SQL Server and your analysis services on two separate machines, you can go in and modify your network packet size on your connection string, which just means that you'll pull more data through. Make sure you baseline your query performance. Okay, so if you are running a series of queries to find out how well your SQL Server or your analysis services environment is performing, please dump the cache. I've seen people run the query and go, oh yeah, look, it's really fast. And then it starts up again and it's like, oh, oops. Because all it does is take those queries, build it into the cache. So it's just like SQL Server. In SQL Server, how you have to dump the cache, the DBCC... Yeah, thank you. I don't think it's worth a speaker though. He was trying. Right, so yeah, make sure you drop the cache. So, we're just about at the end here, guys, so we're going to actually finish fairly early. Is that all right? Yeah. For the hungover people in the room, they go, oh God, thank God for that. So, what is the most important role in SSAS design? Design? DBAs? Okay. Hands up for system admins. Ooh. So, no sysadmins in the room. Hand up for developers. What if I said all of them? Ha-ha! No, every single one of those roles is absolutely critical, because if you don't get the design of the hardware right, and then you don't get the design of the database right, and you don't get the design of the cube right, it's all going to fall apart. Okay? So make sure that you are working together and that you are feeding back to your sysadmins what they need to do to tweak and config and make sure that the server's actually performing the way that it should be, because not all of us have the ability to go and modify the servers. For some strange reason, people don't let us just go in and play as developers. I don't know why. And also make sure you're talking to your DBAs and you're letting them know the types of queries that you're going to be firing at the SQL box so that they can start tuning performance for that as well. And that's basically about it, ladies and gentlemen. Nice and easy, eh? I didn't want it to be too hard for you for the second to last session of the day. You know. Okay, we've got a question. Go.
What's the minimum RAM at
Give me as much as I can have. That's really it. In this day and age, scaling hardware is not like it used to be, right? We can just go out and, well, I do make it sound a little bit trivial, and it's not really that trivial, but we can just go and buy more memory and stick into a box. Or if it's virtual, we can just add more. But start out with as much as you can get. If you have only got 4 gigs available to you, you'll just have to make sure your cube design is awesome. Most of it's the same. The key principles are pretty much the same. I'm a little bit old school, as you guys can probably guess. I prefer the analysis services cubes rather than tabular. Tabular's just not quite there yet. You know, another iteration, and I think it could be. And the direct query side of it is a brilliant idea. And the fact that you can actually build a tabular model over an existing cube to help deal with some of the issues is kind of cool too. But yeah, I'm not quite there with tabular mode at this stage. Has anyone actually implemented tabular mode in production? Yes, I know. Yeah. Who else? You have? Is it working well for you? Yeah? And the users are happy?
Yes, but it's much smaller.
You're right. Does it consume any part of your analysis services cube? Yeah. No. Okay. Other questions?
Yeah, but technology with so quite a big pain point is not having the display folders.
Yeah, the display folders are a real shame, actually. There's also, one of our customers from Fulton Hogan found a bug in Excel that if there wasn't display folders in there or something, every time we went back into it, it forced it to refresh. Yeah. So I think it's an Excel 2010 problem or something, isn't it? Right, okay.
What do you recommend about having database and queue on the same machine?
If you can separate them, do so. But then you have to think of you've got to think of things like your network and the load that it's going to put on there. The problem with having them on the same machine is you've got all these drives you need for SQL Server for starters, because you've got a temp DB, you've got transaction logs, you've got data warehouse database, you know, user database files, etc., potentially partitions, and then you've got the same issue with analysis services. So you end up with all these drives being split across the machine, which is actually not a problem. You can use it, manage it, maintain it, but it can be difficult to have that in a single machine, especially if it's a single piece of hardware, because you just won't have enough physical drives available to you, and you end up having a single RAID array that you then logically partition up, and that doesn't really give you anything, because you're still going through a single RAID card, right? So.
What is the recommended size for 10 GB on?
Sorry, say that again, please.
Recommended size for 10 GB for?
A recommended size for TempDB. Yeah, you'll just have to monitor the usage of TempDB to sort of see what it's doing. So, I don't know. It'll depend on the size of your data warehouse as well, right? If you've got a massive data warehouse that's into the terabytes, you're going to need a large amount of TempDB space.
There's something called user-based optimization in application design. Have you ever used that?
Called, sorry? User-based optimizations and aggregation design. Yeah, I know about it, but I've never used it. So basically, that's a good question. I reckon that's worth the speaker. So user-based optimizations means you capture the queries that the users are executing, and you then play that into your cube, and your cube into Visual Studio, and that will then tell you how you should structure your cube. It's pretty much like what the old indexing wizard used to be like for SQL Server. Similar sort of concept.
Don't do it during the middle of the month.
Yeah. It can take quite some time. So I've never used it in a production environment. I've only ever used it in a dev sort of play environment. Yes?
You mentioned about changing the packet size
Yes.
to something that's really big. Why would you do that instead of just setting it to the MTU for the network?
What? Oh, see. Okay. So changing the packet size to something large, rather than what, sorry?
Rather than just setting it to the MTU of the network so you don't have any wasted space inside your packet.
Yeah. I guess it's just a general rule of thumb, and you could then you would actually have to put something like netmon on and see whether you're actually wasting any space or not. It'll depend on again how large the cube is and the queries that are going through to the SQL database, right? So if the cube queries aren't very big, setting it to a large size is not really going to help very much, right? So yeah, quite a good point. Didn't think about it. Okay, yes. Oh, that's a really good point. Can I do that on this machine? Can you guys see that? Okay, hang on. I know. I'll do it this way. It's all right. You see that one all right? Okay. The best development tool in the world. Here you go. You can see that all right now. It is theta, not the tar. I do get in trouble for saying that. I really shouldn't. Yes?
Would you see customers actually migrating their cubes to the cloud, or do you see
If you are going to put your cube in the cloud, you have to use infrastructure as a service. You've got to stand up a virtual machine. The platform services and offering as part of Windows Azure does not actually have analysis services as part of it. So at the moment, it's not quite there. Now, I was talking to Nicholas Stritzas yesterday, day before, and asking Nick about that, and he says they have no desire yet to put the UDM up into the cloud. The UDM is just a fancy name for analysis services.
Do you see column store indexes staying in this field at some point?
Probably not for analysis services, but definitely for your data warehouse, yeah. Yeah, if you've got a very large data warehouse, you should be looking at your column store indexes.
Something on business objects already there. From a user point of view, if you've got a big data warehouse, sort of weighing on when to build a cube versus using column store index.
It'll come down to the functionality and capability. If they're using Excel to connect to it and browse the data, most business users would prefer to connect to a cube because they get a nice pivot table, right? So that's where the tabular mode could actually play a really strong point for you. You could still have your columns, you could have a really high-performing SQL Server environment with column store indexes and then put a tabular mode analysis services instance over the top of it and just use direct query.
Like business objects or OBRE, you've got that on top of your warehouse already.
Right, I see.
Seeing what they connect to, it's pretty quick.
Yeah. So from those perspectives, those applications wouldn't change. They'd benefit from the column store index. Any more questions? All right, so we're going to wrap it up. Get you guys out nice and early.